Hi, my name is Lisa Reddy, and I'm a sophomore at Doherty Valley High School in Santa Monica, California. Now, my journey to get here has been anything but linear. I've moved 13 times and attended 12 different schools across 3 continents. A couple years ago, I made my biggest move yet, coming to California from India on my own to start high school. Living with my aunt, my uncle, and my 2 cousins while my parents and brother are back home has taught me adaptability. When I'm not in the lab, I'm usually writing for my school's newspaper, reading, or sketching. I've always loved art and drawing because it forces me to look closer at the details. Whether I'm falling into science, history, rabbit holes, or getting lost in existential questions, I'm always trying to understand the how behind the what. I've always been fascinated by the natural world, especially the parts we can hold in our own hands. Since I've moved so frequently, I developed a small habit of taking a rock from every place I lived to make a personal timeline. In elementary school, a teacher showed me how pressure and impact reshape materials and how Earth records its history through minerals. That moment shifted my interest from simple curiosity to a focused interest in Earth and planetary sciences. I also explore real Earth data on my own. Living here in Santa Monica, earthquakes are part of the daily reality, including a 4.2 magnitude earthquake we felt recently. In fact, we even got mentioned as one of the most seismically active cities in the world by SF Chronicles. This prompted me to start tracking seismic activity patterns regularly. This habit of analyzing live datasets is exactly why the NASA sees focus on remote sensing appeals to me. Last summer, the year after my freshman year, I did a research internship at UC Berkeley's Earth and Planetary Science Department under Professor Hans Rudolf Wink. This was a truly great experience and turned my curiosity into hands-on science. I primarily focused on analyzing impact materials from the Arizona meteor crater, specifically studying the deformation of quartz. I prepared over 15 thin sections, polished samples, and documented mineral structures using optical microscopy, SEM imaging, EBSD crystallography, and elemental analysis. Beyond the crater project, I also assisted in research on serpentine samples from the Sierra Nevada, helping to organize imaging and measurement data. I'm currently helping to finalize data for an ongoing research paper with the team, which has taught me the discipline required for scientific publication. Now, throughout all of this, what mattered the most to me was the collaboration. I got to work closely with PhD students and ask questions constantly, learning to refine results through the feedback that I got. The lab showed me what real scientific work looked like and strengthened my confidence in tackling complex problems. Sharing science is just as important to me as the research itself. Following my time at Berkeley, I partnered with Professor Lung Chan to conduct outreach at local schools. I gave presentations on planetary sciences using my own lab images to show students the tiny, fascinating structures that our world is built upon. As the outreach manager of my school, SweNext, I bridge the gap between curiosity and career. I've organized STEM nights and workshops ranging from CAT sessions to resume building in collaboration with mentors from Georgia Tech. We even coordinated college lab visits to help younger students visualize their own future in science. Whether I'm tutoring STEM subjects or volunteering through CSF, I've realized that the most significant scientific impacts happen when we communicate and work together as a team. But I think I've learned the most from Model UN, where winning research awards taught me how to take a mountain of information and turn it into a solid argument. That same focus is what gets me through track practice as a JV sprinter. I've learned that you should be willing to put the work in, even when nobody's watching. Now, I know I've spent the last couple of minutes talking about my background, my accomplishments, but now I want to talk about why I want to be a part of this mission. For me, NASA's represents the ultimate application for where the questions I've been asking my entire life can be answered. My path in environmental science stems from a deep desire to understand how to protect and sustain the only home that we have, and I personally think that being a part of NASA's would help me get closer to that goal. I'm drawn to this program because I want to be in a place where curiosity is a requirement. I want to learn how to turn raw planetary observations into a language that can help us build a more reliable future. I want to look forward to the challenge of being pushed by my mentors and peers who look at the world the same way I do. I'm ready to contribute to this team from the very first day. Moving across the world at 14 didn't just teach me how to adapt to a new school, it taught me how to be observant, how to stay disciplined when things get hard, and how to find my own footing at an unfamiliar territory. Now, I bring a perspective that has been shaped by many different cultures and environments, which allows me to look at a problem at many different angles before finding the right solution. Thank you for your time and consideration for my journey. Bye!